One of them is the equal space arguments. Number two is unequally spaced arguments. Unequally spaced arguments we have a Newton divided difference formula. Newton divided difference formula. And difference table are required. Difference table is required. So we have to construct a divided difference table. Difference table is divided difference table is required. In equal spaced argument formula, Newton forward formula is required. Newton forward formula is a corollary of Newton divided difference formula. It means we can reduce Newton divided difference formula into Newton forward formula by some assumptions. So this formula which is written here is known as Newton divided difference formula. In this formula, what is given? X naught, x1, and so on, xn minus 1. These arguments on which I placed a tick are given to you. And more things which are given to you are the entries. The entries are also be given to you. These are the entries. This is the direct entry, but this is the calculated entry by a difference table. So these are the entries from the divided difference table. So if we have a divided difference table, so these entries can be obtained from there. I will give you a complete example on the next slide regarding this formula. So these are different values of B naught, B1, B2, Bn. So these B's can be computed by difference table and then multiplied by these brackets. So this is called Newton divided difference formula. So I am using this Newton divided difference formula because this is the second lecture on the Newton divided differences. So I'm going to complete one example of Newton divided difference formula on the next slide. What that formula is and what that example is, these are the divided differences: zeroth order divided difference, first order divided difference, second order. So as many entries we have in the bracket, 1 minus that is the order of the divided difference. So if I have 3 entries in the bracket, 1, 2, 3, so it is second order. If we have 2 entries in the function, then it is first order. And this is the order of not kth, this is k minus 1 order. K minus it is 0, 1, 2, 3 the second order, 0, 1 first order. Yes, you are right. This is kth order. Kth order. Why kth order? Because it is started from 0. If it is started from 1, suppose I am interested in f x1, x2, and xk. So this is not kth order. This is k minus first order. Why this is k minus first order? Because these are the k entries and the k minus 1 is the order. In these, we have started by 0. The total number of arguments will be k plus 1. So therefore, it is of the kth order. Total number of argument 3, the second order. Total number of arguments are 2, the first order. So this is the recognition of the divided differences. This is the generalized formula of Newton divided differences. So we can call it as Newton divided difference formula. This is the same formula as written on the previous slide, in which the values of b's are to be determined. The values of b's are these, and these are the product brackets. If I expand this for n is equal to 2, so for n is equal to 2, we have to go, this is the product sign, not a summation sign, and this is the summation sign. So this we can call it as a general form of Newton divided difference formula. General form of Newton divided difference formula. I am writing this for n is equal to 2. For n is equal to 2, we can write down it as f2x. This is equal to summation for I is equal to 0 to 2. So if I am putting 0, so this will be equal to the f of 0 we have here. And here we have j is equal to 0 up to I minus 1. So if it is 2, so we have 0 to 1. So 0 to 1 means we have x minus x naught and the value of I will be 0. If a value of I will be 0, we have 0 minus 1, it is minus 1. So we cannot put 0 here because it will be the negative 1. If I put 1 here, so this will become j is equal to 0 to 0. So 0 to 0 will also be the 0. If I put 2 here, so this will becomes 0 to 1. So 0 to 1 means what? So we have x minus 0 and x minus x1. The two brackets we will have x minus 0 and x minus x1. And if it is x minus 0 and x minus x1, so 1 minus that we have here, x0 and x1, x0 and x1 and x2. So you can see the expanded form here in this. If we have b naught means the fx naught. B naught means the fx naught. B1 means fx naught x1. We have x minus x naught and x minus x1. Then we have fx naught x1 x2. So we have x minus x naught, x minus x1, x minus x. Well, that's all. X minus x naught, fx naught, fx naught x1, x minus x naught. It will not be here. This will not be here. Then we have fx naught x1, x2, so x minus x naught and x minus x1. Two brackets we will have, and so on. In the same way, if one argument will be increased here, and one bracket will also be increased here. In the same way, you have to proceed for the rest of the terms in this formula. So this is the explanation of the formula. Now we have to implement this formula here. Suppose we are interested, entries of the divided difference table are obtained from the data table using the simple operation. These entries are obtained. As I told you how these entries are obtained. minus 5. Minus 5 can be obtained by uh, minus 3 and minus 5 divided by 1 minus 0. Minus 3 minus minus 5. So this will be plus 5. So this is equal to 2 upon 1. So that is why we have 2 here. And this is represented by f of x naught, x1. Now how this 6 will be obtained? This 6 can be obtained by minus 15 and then minus minus 3. So this will be equal to the plus 3 divided by minus 1 and then again minus 1. So this becomes minus 18. This becomes minus 2. This is equal to how much? Not 18, sorry. We have to subtract it. So this will become 12, not 18. Because we have to subtract 3 from 15. The 2 6 are 12. We have 6 here. Now how minus 4 is obtained? Minus 4 can be obtained by 6 minus 2 divided by minus 1 minus 0. So 6 minus 2 becomes 4 divided by minus 1 minus 0 becomes minus 1. So that is why we have minus 4 here. So you can see the calculation of these divided differences as I told you in the previous lecture how divided difference table can be obtained. So you can see the table of divided differences in this way. Now in the next slide we have to find out. This is the explanation as I told you how these numbers are calculated in this table. Second number, how the second number is calculated, how the next number is calculated. So this is minus 4 can be calculated by 6 minus 2, as you can see here, divided by minus 1 and minus 0. This is minus 4. Now, this is the generalized formula. f2x is equal to minus 5 plus 2 x minus 0 minus 4 x minus 0 x minus 1. So these numbers are plugged in and you will get a formula which is a second order formula. Why it is second order formula? Because we have x into x, that is x square into this. So minus 5 plus 2x minus 4x square and some other terms we have. So this is the expansion of this formula. Generalized form of the formula is this, and specialized formula with the help of the divided difference table, we can summarize it like it. Now, obtain interpolating polynomials for 2 examples. So these are the 2 different examples, 1 to 3, 2, 1, 3. And we are interested to obtain the polynomial. So you can see that the polynomial is same. If I expand this, the same expansion for this table and the same expansion by this table and simplify, so we have the same polynomial x square minus 1, x square minus 1. So what is the ultimate observations that the 2 polynomials are identical? The reason is divided differences does not change by changing order. Means what? Suppose we are interested in fx naught x1. This will be the same as fx1 x naught. Fx1 x naught and fx naught x1 both are same. Similarly, if we have fx naught x1 x2, this is same as fx2 x1 x naught, and this is same as fx2 x naught x1. So all of these three entries in a divided differences are identical. So this is the conclusion. Ordering the points should not affect the interpolating polynomial. So this is the one conclusion about this identity. What the identity is, if we are changing the order of the entries in the divided differences, then the value will not be changed. All values remain same. Ordering of the polynomial should not affect the interpolating polynomial. This is the conclusion. By this conclusion, we have x naught, x1, x2, x1, x2, x naught, x1, x2, x1, x naught. All of these three polynomials will be same. What will be the degree of the polynomial? The degree will be the second order polynomial. If I have three arguments within the bracket, then second order polynomial we will have. Now find a polynomial of this data. So how polynomials can be obtained? By a difference table. This is x naught, this is x1, x2, x3, x4. This is fx naught, fx1, fx2, fx3, fx4. Now you have to construct a difference table. So that difference table is already here. How these entries are computed, I'm just explaining the one only one. Suppose how this 4.5 is calculated. This 4.5 can be calculated by differencing 5 and 4, because this 4.5 is in between these two, and this minus 1.6 is in between these two. So 5 minus 4. So this can be calculated as 5 minus and a minus 4 divided by 6 minus 4. Now you can calculate this number. This number will be 4.5. This is 9. And this is 2. 9 divided by 2 becomes 4.5. So this number is calculated. How this 0.6 is calculated? Minus 1.8 minus 1.5 divided by 7 minus 2. So this can be calculated by 7 minus 2. All the arguments will be used in denominator to find out this. Then all of the values are to be substituted into the Newton divided difference formula. F4 can be obtained by these numbers are to be used. Which numbers are used? These numbers. This is 3. This is 1. This is minus 1.6. This is 1.5. This is 0.6. These numbers are to be used. So you can see these numbers here. This is 1. This is 3. First number is 3. Then second number is 1. Next number is minus 1.6. Then the next number is 1.5. And the last number is 0.6 minus 0.6. So these are the numbers. And what other terms are there? X minus 2. This is 2, which is used. Then x minus 2 and x minus 4. Then x minus 2, x minus 4, x minus 5. Then x minus 2, x minus 4, x minus 5, x minus 6. And that is the last one. If I expand this, so we have a fourth order polynomial, because these are the 4x which are in product in one term. So we have a fourth order polynomial we have. Now, interpolating conditions for fxi nth order polynomial. If we are interested, the interpolating polynomial is unique. Different methods can be used to obtain it. We can use divided difference, we can use Lagrange interpolation, and we can use other formula as well. Lagrange interpolation and Newton divided differences both are equivalent. You can see this in section number 18.2, Lagrange interpolation, and Newton divided is that which is in the previous slide we have. Ordering the point should not affect the interpolating polynomial. Interpolating polynomials remains same. It does not affect by changing the order of the polynomial. So now we have a Lagrange interpolation in the next. The Lagrange interpolation can be seen in the next slide. I am just giving you the opportunity to ask the question. We have all formulas. What we have, first category of the formula is equal spaced, and unequal spaced. Unequal spaced can also be bifurcated into divided differences and Lagrange. Lagrange is a formula which I will describe on the next slide. And equal space can be split into three forms: forward, Newton forward formula, Newton backward formula, and one more type of interpolation we have. This is known as central difference interpolation. Central difference interpolation. It's totally depend on the missing entry. Okay, missing is where? The equal spaced and unequal space, you can identify it very easily if the given arguments are having same distance among themselves. So we can apply equal spaced. If the arguments are does not have a same difference in the values of x, so we can apply the unequal spaced. Suppose this is given to you: 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So is this an example of equal space or unequal space? So the answer is yes. This is the example of equal space, because 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is 6, 2. So we can apply equal spaced. Up totally depend on whether forward, backward, or central. Suppose I am interested to find out F3. because 3 is not there. If I am giving you 3 against 3, you have to find out the y or the missing entry. So this can be done by the forward. Forward means initially in the table the missing number is there. If it is in the bottom like 8 and 10, so we can apply backward. This is F8. So if you have to estimate F8, you can use backward. If it is in center, center is 6, exact center is 6. If it is missing from 5 or if it is missing from 7, so we can use central differences. So F5 or F7, these two can be estimated with the help of central differences. So this is basically the three difference. Or if the table is unequally spaced, like 2, 4, and instead of 10, I have 12 here. So all over there, I have a gap of 2, but here we have a gap of 4. So this becomes unequal space. In unequal space, I have the two options. Either I can use the divided differences or I can use the Lagrange formula. So these are the two options which I can use for interpolation. Lagrange formula can be derived by using by the expansion. So as we initially expand fx naught x1, this can be written as fx1 minus fx naught divided by x1 minus x naught. This is what? This is expansion of our divided difference. This is first entry of first order divided difference. This is not second order, this is first order, because order can be determined by 1 minus. There are the two arguments minus 1. This is the order, and 0 plus 1, this is the first entry. This can be expanded as fx naught divided by x naught minus x1 plus fx1 divided by x1 minus x naught. I derived this in the last lecture. Fx naught divided by x naught minus x1, fx1 divided by x1, fx1 divided by x1 minus x naught. So this is the expansion. Now suppose I have fx naught, x1 and x2. So this can be written as fx naught divided by x naught minus x1, x naught minus x2 plus fx1 divided by x1 minus x naught, x1 minus x2 plus fx2 divided by x2 minus x naught and x2 minus x1. This is first entry of second order. So in the same way, if I have f x naught, x1, x2, x3, so very simple. In the first term, you have fx naught. In the second term, you have fx1. In the next term, you have fx2. And in the last term, you have fx3. And in plus we have all over there, we have plus. And in denominator, we have all brackets. What all brackets will be there? X minus x naught minus x1 up to x naught minus x3. Except only x naught minus x naught, I have all brackets. Here I have x1 minus x naught, except only x1 minus x1, I have all brackets. x1 minus x3. In this, I have x2 minus x naught and up to x2 minus x3. Except x2 minus x2, I have all bracket and so on. In denominator, I have all bracket except only x3 minus x3. So x3 minus x naught and up to x3 minus x2. So x3 minus x3 is not there, all are there. So this is the expansion of divided differences. I will use this expansion for the derivation of Lagrange formula. Because what is there? This is the entry in the divided difference table. This can be written without a difference table. So we can see that there is no difference table is required on the right hand side, because on the right hand side what we have fx naught, fx1, fx2, these are the direct entries. Without difference table we can construct that, and denominator we have the differences of the arguments. So without difference table we can have this entry. So this is the technique which is used for the derivation of the Lagrange interpolation formula. Now we are interested in Newton divided Lagrange formula. Derive the Lagrange formula. Suppose we have some given items x naught, fx naught, x1, fx1, x2, fx2, and x3, fx3. Suppose these paired observations are given to us, and we have one argument xk, against xk yk is missing. Yk is missing, and we have to estimate that. We have to estimate yk. Yk means fxk. We have to estimate fxk. So this is to be estimated. Fxk, or I'm just writing x instead of xk. I'm just writing x. X naught, x1, x2, x3. According to the definition, this can be expanded as fx divided by x minus x naught, x minus x1, x minus x2, x minus x3, plus fx naught divided by x naught minus x naught minus x1, x naught minus x2, and x naught minus x3, plus so on. What will be the last term? Last term will be fx3 divided by x3 minus x3 minus x naught, x3 minus x2, x3 minus x3 will not be there. So this will be the x3 minus x naught minus x1. This will be the x3 minus x1. And this will be the x3 minus x2. So this will be x3 minus x1 and x3 minus x2. So this is the expansion as I told you on the previous slide. This is. According to the definition, if I have these four entries, to the fifth order divided differences will be 0. Fourth order divided differences will be constant, and the fifth order, this is the fifth order. Why this is fifth order? 1, 2, 3, 4, 5. Not fifth order, this is the fourth order. There are the 5 arguments in the bracket. So that is why we have fourth order. The fourth order will be constant and the fifth order will be 0. So I'm just putting it to the 0 because this entry will be 0. And right hand side we have as it is this plus this and so on. I'm not writing the entire right hand side again, but I'm just giving you the left hand side will be 0. Why the left hand side will be 0? Because if we have given the 4 arguments, then the third order divided differences will be constant and the fourth order divided differences will be 0. So in this case, I have 1, 2, 3, 4 arguments are given to us. The third order will be constant and the fourth order will be 0. So this is 0 according to the definition. So if I plug in this to the 0, so this is, I'm just putting it here because writing entire expression will take a lot of time. So this is 0. So this is second step. So in the second step, nothing is there. I just put the left hand side to the 0 because this entry will not exist in the divided difference table. Now the derivation is very simple. So you have to do one thing only. What is required? The required is fx k yk. This is required. So this is unknown, which is required. Take all terms to the opposite side. So this is on the left side, this is on the left side, right side. If I take all of these terms to the left side, so this can be written as fx is equal to, all these brackets will be in denominator I have, and this term by taking to the left hand side can be written as, so here I have a equal to sign, and this is a negative term. Why this is negative term? Because I took this term to the left hand side. So initially this was on the right side, on the left side there was 0. I took the entire first term to the left side, then the left term becomes negative and the remaining terms are as it is there. So now I have to do one thing. What that thing is, I need fx. If I need fx, so I multiply these brackets by the entire expression. So on the left side, these brackets will be cancelled out and took to the right hand side in numerators. And then this minus sign I will dissolve. How I will dissolve this minus sign? I will explain it. So on the left hand side, we have only fx minus fx. And all of these brackets will becomes the numerator here by cross multiplying. So here I will have x minus x naught, x minus x1, x minus x2, x minus x3. These brackets will be all over there in all terms. X minus x naught, x minus x1, x minus x2, x minus x3. All over there we will have, and from denominator this is cancel out. From denominator it is cancelled out. So on the left hand side we have only minus fx. We have only minus fx on the left hand side, and all the terms I took on the right hand side by cross multiplication. So we have this expression. Now we need fx. One more amendment has to be do here, and that amendment is what? It is x minus x naught. This is x naught minus x. Can I cancel out these two terms? So I cannot cancel out these two terms because negative sign, there is a difference of negative sign in these two. So this negative sign, I am going to make it plus. If I am going to make it plus, then all of these terms will have a negative sign. So this is a negative sign. Instead of plus, it is negative. This is negative. This becomes negative. So now these terms are the negative terms. So this negative sign has been eliminated. If I change the x minus x naught to the x naught minus x, so x naught minus x I have here, x naught minus x I have here. So this term will be cancelled out along with the negative sign. Negative sign will also be cancelled out. Why the negative sign is cancelled out? Because the order a minus b, this is b minus a. So a minus b, this is like this. A minus b, in denominator I have b minus a. So what is the answer? The answer is, if you have a negative sign here, the answer is 1. Because this minus sign can be taken here, the b minus a, b minus a, and b minus a, b minus a will cancel out. So from the all terms, one bracket will be cancelled out. You can see. Here I have x minus x3. And here I have x minus x3. So this x minus x3 will be cancelled out with this x3 minus x along with this negative sign. So now I have a finalized formula. What the formula is, I am writing the formula here, and then we'll give you the chance to ask the questions. Then this is equal to fx naught x minus x1, x minus x2, x minus x3. In the product, I have fx naught divided by x naught minus x1, x naught minus x2, x naught minus x3 plus fx naught, then I have fx1. And all brackets I have here, x minus x naught, x minus x1 will not be there, x minus x2, x minus x3 divided by x1 minus x naught, x1 minus x1 will not be there, x1 minus x2, x1 minus x3. Then I have fx2, and all over there I have x minus x1, x minus x1. Instead of x minus x2, I have x minus x3. And in denominator, I have x2 minus x naught, x2 minus x1. x2 minus x2 will not be there, x2 minus x3. And in the last term, I have fx3, and brackets will be x minus x naught, x minus x1, x minus x2 divided by x2 minus x3 minus x naught, x3 minus x1, x3 minus x2. This formula is known as Newton divided difference. No, this formula is known. Suppose this data is given to us. 2, 4, 6. These are the 4 points. These fx are also be given to us. 9, 3, 7, 2. These are fx. These are x. One unknown x is there. Against the unknown x, the entry is missing. So we have to put the values here. What the values will be? Fx is equal to, we have x minus x1. x1, this is x naught, this is x1. X minus 4. X minus 4. Then x minus 6, x minus 7. And fx naught is 9. Denominator mein, in the denominator we have x naught minus x1. This is x naught, this is x1. So 2 minus 4, 2 minus 6, 2 minus 7. This is first term. In second term, what we will have? In second term, we have x minus x naught. X minus x naught means x minus 2. X minus x1 nahi. So x minus x2 is x2, x minus 4. Then x minus 4 will not be there. X minus 6 will be there. Then x minus 7. In denominator we have x1 minus x naught. So this is x1, this is x naught. So 4 minus 2, 4 minus 6, 4 minus 7. And in product we have fx1. The fx1 is this 3. So we have a 3 here plus then we have x minus x naught, x minus 4, not 4, x minus 2, sorry. X minus 2, x minus 4, x minus 6 will not be there, x minus 7. Multiply by 7. In denominator we have 6 minus 2, 6 minus 4, and 6 minus 7. And there will be the last term. In this last term, we have x minus 2, x minus 6. One more bracket, we will have x minus 4. X minus 4, x minus 6, x minus 7 will not be there. Here we will have 7 minus 6, 7 minus 2, 7 minus 4, 7 minus 6, and in the product we will have 2. This is called Lagrange.